Your engine hesitates during acceleration and the dealership quoted you $800 for a throttle body replacement that you probably don't even need. Hold off on that expensive repair because I'm about to share 6 proven methods to reset your throttle position sensor that have saved my customers thousands over the past 12 years. Each technique targets specific symptoms, and I'll reveal the insider trick at the end that prevents this issue from recurring for over 60,000 miles. Let me start with the ECU power cycle method, which works exceptionally well on vehicles with drive-by-wire systems experiencing erratic idle patterns. This approach shines when your car stalls at traffic lights or the RPMs fluctuate wildly without any apparent reason. Park your vehicle on level ground and engage the parking brake firmly to ensure complete stability during the procedure. Remove the key from the ignition and wait at least 5 minutes to allow all electronic modules to power down completely. Locate your vehicle's ECU fuse in the main fuse box, typically found in the engine compartment near the battery. Pull the ECU fuse using needle nose pliers and set it aside in a safe location where it won't get lost. Wait exactly 8 minutes with the fuse removed to ensure complete memory erasure from the engine control unit. Reinstall the ECU fuse firmly into its original position and listen for the distinctive click that confirms proper seating. Insert the key and turn to the accessory position without starting the engine, allowing all dashboard warning lights to illuminate. Press the accelerator pedal to the floor slowly over 7 seconds, then hold it down for exactly 5 seconds. Release the pedal gradually, taking another 7 seconds to return to the rest position. Repeat this complete sequence 5 times without rushing any step of the process. Turn the key to off and remove it completely before waiting 20 seconds for the system to process the new calibration data. Start the engine and let it idle for 30 minutes without touching the accelerator to complete the learning cycle. The second technique uses the mass airflow sensor disconnect method, particularly effective on turbocharged engines with boost-related throttle issues. Begin by locating the mass airflow sensor between the air filter housing and the throttle body assembly. Disconnect the electrical connector from the MAF sensor after taking a photo of the wiring configuration for reference. Start the engine and let it run for exactly 3 minutes in this limp home mode while the ECU adapts to the missing sensor input. The engine will run roughly, but this is completely normal and necessary for the reset procedure to work properly. Turn off the engine and reconnect the MAF sensor, ensuring the connector clicks securely into place. Restart the engine immediately and maintain idle speed for 25 minutes to allow both sensors to recalibrate together. This dual sensor approach often resolves complex throttle response issues that single component resets cannot address. Right now would be a perfect time to subscribe to this channel and hit that notification bell, because these professional-grade techniques I'm sharing could save you more money than a year's worth of premium cable subscriptions. Method 3 involves the throttle body cleaning reset, essential for high-mileage vehicles with carbon buildup affecting sensor accuracy. Ensure the engine is completely cool before attempting this procedure, ideally after sitting overnight in your garage. Disconnect the negative battery terminal using a 10mm wrench and secure the cable away from the battery post. Remove the air intake tube connecting the air filter housing to the throttle body, typically held by spring clamps. Locate the throttle body and carefully disconnect the electrical connector after documenting its position with your smartphone. Use only throttle body specific cleaner, never carburetor cleaner or brake cleaner, which can damage the delicate coatings. Spray the cleaner onto a lint-free cloth and gently wipe all internal surfaces without forcing the throttle plate movement. Pay special attention to the throttle plate edges where carbon deposits typically accumulate and restrict proper sealing. Allow the cleaner to evaporate completely for 15 minutes before reassembling any components in reverse order. Reconnect the battery and perform the basic pedal reset sequence 3 times before starting the engine. Let the engine idle for 40 minutes to complete the extended learning cycle required after physical cleaning. The fourth approach utilizes the OBD scanner reset function, providing the most precise calibration available to home mechanics. Connect your OBD scanner to the diagnostic port located beneath the dashboard on the driver's side. Navigate to the engine management menu and select the throttle body adaptation or relearn function. Follow the on-screen prompts, which may require specific key positions or engine states depending on your vehicle manufacturer. This method allows real-time monitoring of the throttle position values during the reset process for verification. Save the before and after readings to document the improvement and identify any remaining issues requiring attention. Clear all stored error codes after completing the adaptation to ensure a clean slate for the learning process. Method 5 combines temperature cycling with electrical reset for vehicles in extreme climate conditions. This technique proves invaluable for cars operating in desert heat or Arctic cold, where thermal expansion affects sensor accuracy. Begin this procedure when the engine temperature gauge reads exactly in the center position after normal driving. Immediately disconnect both battery terminals and wait for the engine to cool completely to ambient temperature. This thermal cycling helps the metal components return to their manufactured dimensions for accurate calibration. Reconnect the battery when the hood temperature matches the outside air temperature, typically after 2 hours. Perform an extended pedal sequence with 10 repetitions instead of the standard 3 to account for thermal variations. Start the engine and run it through multiple temperature cycles by driving for 20 minutes, then idling for 10. The sixth technique addresses modern vehicles with advanced driver assistance systems that integrate with throttle control. Disable all electronic stability control, traction control, and adaptive cruise control systems before beginning the reset. These systems can interfere with the throttle learning process by making micro adjustments during calibration. Access your vehicle's infotainment system and navigate to the vehicle settings menu to disable these features temporarily. Perform the standard reset procedure with all assistance systems deactivated to ensure pure throttle response learning. Re-enable the assistance systems only after confirming smooth throttle operation through city and highway driving tests. During my years servicing these systems, I've discovered several environmental factors that dramatically influence reset success rates. Barometric pressure changes during weather fronts can affect the air density calculations used by the throttle position sensor. Avoid performing resets during approaching storms or significant weather changes when atmospheric pressure fluctuates rapidly. I've documented reset failures occurring within hours of major weather systems passing through the area. Plan these procedures during stable, high-pressure weather patterns for the most consistent and lasting results. Fuel octane rating plays a more significant role in throttle response than most people realize or mechanics admit. Lower octane fuels burn differently and can cause NOx sensors to retard timing, affecting throttle calibration accuracy. Use premium fuel for at least 2 fill-ups before attempting any reset procedure to ensure consistent combustion characteristics. The additional cost pays for itself through improved reset reliability and extended periods between required recalibrations. Engine oil viscosity affects internal friction levels that the throttle control system must compensate for during idle speed management. Thicker oils in cold weather increase internal resistance and can throw off the idle speed learning algorithms. Switch to the manufacturer's recommended winter viscosity oil before cold weather resets to ensure optimal results. I've seen reset procedures fail simply because customers used summer weight oil during winter calibration attempts. Air filter restriction levels influence airflow calculations that directly impact throttle position sensor accuracy and learning capabilities. Replace your air filter if it shows any discoloration or debris accumulation before attempting throttle system resets. A partially clogged filter forces the throttle to open wider for the same airflow, skewing the calibration parameters. This seemingly minor detail can determine whether your reset lasts 3 months or 3 years. Intake manifold vacuum leaks create inconsistent airflow readings that confuse the throttle position learning algorithms. Listen carefully for hissing sounds around vacuum hoses and intake connections with the engine running at idle speed. Even small leaks can prevent successful throttle calibration by introducing unmetered air into the combustion process. Address any vacuum leaks before attempting resets to avoid repeating the procedure within weeks of completion. Throttle body mounting bolt torque affects the sensor's physical alignment and can introduce mechanical stress that skews readings. Check that all mounting bolts are tightened to manufacturer specifications using a calibrated torque wrench. Over-tightened bolts can warp the throttle body housing, while loose bolts allow vibration-induced measurement errors. This mechanical precision often separates successful long-term calibrations from temporary fixes that fail prematurely. Engine mount condition influences vibration transmission to the throttle body assembly, affecting sensor stability during calibration. Worn engine mounts allow excessive movement that prevents accurate throttle position learning during the reset procedures. Inspect motor mounts for cracking, separation, or fluid leakage before performing any electronic calibration work. Replace damaged mounts first to provide the stable platform necessary for precise sensor calibration. Fuel injector cleanliness affects combustion stability, which directly impacts the idle speed control algorithms used during calibration. Add a high-quality fuel system cleaner to your tank before beginning reset procedures to ensure consistent fuel delivery. Dirty injectors cause erratic combustion that prevents the throttle control system from establishing stable reference points. This preparation step significantly improves reset success rates and extends the time between required recalibrations. Document every reset procedure with detailed notes including date, mileage, weather conditions, and specific method used. Track the duration between resets to identify patterns specific to your driving habits and environmental conditions. Some vehicles develop unique characteristics that only become apparent through systematic long-term observation and record-keeping. These professional methods and insider knowledge provide everything needed to maintain your throttle position sensor without expensive dealer visits. You now possess techniques that many shops charge premium rates for without delivering superior results or lasting solutions. If this comprehensive guide has saved you money and frustration, show your support by subscribing and enabling notifications to receive my upcoming professional secrets that will revolutionize your approach to automotive maintenance and repair.